Right. While since people have already started unofficially, let's say, coming in without the usual knocking sound, I guess we may as well unofficially start as well. And since I'm the host, I guess it's my job to welcome you. First of all, welcome to all our panelists and esteemed program committee members, and big thanks for being here today, and of course for being members of the program committee and for contributing to this event in various ways. And a big welcome to the people joining us today as well. And yeah, the idea here today is basically that we're going to have like a light discussion. So we're going to go through the topics of the event, Connected Data World 2021, and we're going to pick and choose our favorites, let's say, and then we're going to just discuss and see what we'll most look forward to. And let us start by introduction. So I'll go first. I'm George Anadiotis. I'm the managing director of Connected Data World. That's actually one of the hats I wear. I wear a number of hats. I also write for a few publications, ZDNet and VentureBeat. I'm an analyst working with GigaOM. Actually, just recently, we published a report on graph databases, which may be interesting for some of you. I work as a consultant and, well, a few other things, but let's keep it nice and short. And I'll pass the baton to the next person. So let me randomly choose, as we have the gallery view here, the one to my left. So Andrea Volpini, you go next.
Yeah, hi everyone. My name is Andrea. I'm co-founder and CEO of WorldLift. We work by creating knowledge graph for automating search engine optimization. So we are in between marketing and the graph world.
Great, thanks, Andrea. Then let's keep it. Let's keep passing to the next person to the left. So then it's you, Katariina.
Hello, everyone. My name is Katariina Kari. I'm a lead ontologist at IKEA Systems, which maybe you don't know, but IKEA is a franchisee. And then the warehouses or the stores are run by different companies to which who are franchisors. And so the franchisee is basically responsible for the entire concept and also licensing it. And now IKEA is doing big leaps in terms of digitalization, even though its web store has been around for 20 years, but now, and I'm part of that story. I mean, it's a lot of people doing that, but I'm part of that story in terms of building a knowledge graph there. Previously, I've worked at Zalando, Europe's biggest e-commerce platform for fashion and lifestyle. And before that, I was in classical music and doing various digitalization projects for that art area. And before that, I was a project researcher of semantic research at the Helsinki University of Technology. So I've been like 14 years in the domain now, almost. That's me. And I guess the next one is, if I then go down and right, it's Ashleigh.
Yeah, it is. Thank you, Katariina.
So hello, my name is Ashleigh Faith. I have a day job at EBSCO Information, which is one of the largest aggregators of scholarly research, and I work primarily on the knowledge graph there behind search or recommendations and sense making. And then I have a thing I do in my spare time, which is a YouTube channel where I teach people about knowledge graphs and machine learning and other fun things in the data science world. I think it's Panos is next.
Yeah.
Thank you, Ashleigh. Hello, my name is Panos Alexopoulos. I also have around 15 years experience in the semantic technology field. And currently I work as a head of ontology at TextKernel. So TextKernel is a company that builds semantic software for matching people and jobs. And so it's about the recruitment and labor market domain. And my team is responsible for building a large knowledge graph on this domain.
Great. Thank you, Panos.
And yes, yeah, Ivo.
Yeah, hello everyone. My name is Ivo. I've been in IT in various roles for about 25 years, and my involvement with knowledge graph is in the last 10 years. I'm an independent consultant. I do also trainings, data strategy, and guide implementation projects with knowledge graphs.
Great. Thank you very much, Ivo. All right. So I guess the next step in setting the stage, trivial as it may seem to some of us at least, would be, I thought it would be good to start by defining what do we mean by connected data, because, well, it's a kind of large-ish and definitely heterogeneous area. And in our definition, there are a few basic pillars, let's say, that define that. And so those are graph analytics and graph data science, semantic technology and semantic web, knowledge graphs, graph databases, and as of late, graph machine learning and graph AI. So as I was having also this discussion of how to set the stage and how to explain what connected data is with a few co-panelists the other day, because well, not everyone is familiar with that. One of them had a very good idea. He said, well, how about approaching that in a timeline kind of fashion? And so I think if we are to do that, then probably we'll have to go back to the 17th, 18th century when graph theory was founded, you know, the famous bridges of Königsberg problem, which led to the development of graph theory by Leonhard Euler. And so in a way, that was the beginning of graph analytics and graph algorithms. And I would define that category, let's say, that subcategory of connected data as, well, the use of algorithms that help people derive useful analytics. We have different classes of algorithms like shortest path and proximity. And depending on the class, the different classes of algorithms, this can be very useful in use cases such as anti-fraud or recommendations and so on and so forth. So historically, let's say that's the first area. And just to pass on just to give the opportunity to someone else to say something about the different subdomains. I think if we keep the historical timeline, then probably next in line would be semantic technology and semantic web. So whoever wants to pick it up and say a few words about that. I know you can all do that.
Well, before we move on to that, I will have to say that ontologies actually date farther back than that. The Greek philosophers were talking about ontology as a theoretical way of thinking about things. So I just wanted to point that out, because I think that the theory behind it and connecting things in a class-like structure, I think, is not incredibly new, even from your perspective, George.
That's true. That's true. It depends on, you know, where you choose to draw the line, basically. Yes. Yeah. If you want to go all that way back, yes, you can definitely. Okay. So who wants to pick up semantic technologies and semantic web?
Well, I would also like it just introduce one more before that, which is kind of everything around description logics already in the 70s. So that kind of reasoning or ideas for reasoning that existed there already. I have to honestly say that during my technology studies and research, there wasn't a lot of that taught at universities, which is interesting. So when I arrived at semantic web, it was all about semantic web and here, but that history that what happened in the 70s, like those like deterministic ideas of calculating things and getting more truths out of one truth, what now is known as reasoning for us in semantic community, that pre-work I think should also go into that timeline.
Yeah, that's a good point.
The beginning of the semantic web, I think, is right after that. Like if you're looking at how things are connected together, most people talk about semantic web as like Tim Berners-Lee is like the first, but he was actually building off of a lot of things that DARPA and AlohaNet and some of those things had developed in the late 60s, early 70s, where, the internet wasn't a thing yet other than like MIT, Stanford, and, whatever that triangle of universities was. But that's where it all began. A lot of the things that Tim Berners-Lee outlined with hyperlinks and, cool URLs and all that, URIs, that all stems from the ability to actually connect other systems together.
Yeah, and to add to Katariina's point, I also remember back in the early 90s, and I'm showing my age now, when we had like this AI class in the university. It was kind of a fringe class actually. Back then, not many people were interested. Not many people took that class, and it was kind of weird with all these symbols and reasoning and all of that stuff. It was, to me, vaguely interesting, but well. Just to add to Katariina's point about description logics and reasoning and all of that. So yes, it goes back even before the semantic web.
Well,
I think there were two parallel streams. One was one that for expert systems, symbolic reasoning, this kind of work. Then in parallel with that, it was just the idea about interoperability. So we found a way to represent and share content, HTML. Then it was time to do the same with data, and this is how RDF appeared.
Mm-hmm.
A comment to what George said earlier about the not so in as you said, early 90s. It was just in the beginning of a new decade, and then decade before we had already passed an AI winter, with especially with respect to expert systems, which was a big thing in the 80s, and then they proved not to be scalable, etc. And I guess they thought, okay, now that we have started connecting things and we have the internet, let's try to apply the idea of semantic networks, which is actually also a very old concept at a higher scale. What I think the semantic web community may miscalculate it a bit was the challenge of scaling semantics and scaling meaning, because indeed RDF came and it's a decent, let's say, standard and format, but there wasn't. But it was, let's say, in my view, it was treated a bit as a holy grail, in the sense that it's enough to represent things in RDF and semantic interoperability will come. So let's say the effort on defining RDF and building the infrastructure of RDF and the effort on the ontology engineering aspect, I don't think they were equivalent, or at least as enough to ensure that, okay, we can use RDF in the correct way, so that we have scalable semantics. And in my view, many of the linked data that are out there are not as usable as the semantic web community proposes they are. Mm-hmm. They're really important to have, and especially for research purposes, etc. But at least in my experience, my recent experience, I have had very little incentive to either reuse or even worse, or even better, to connect to these data sets. And I think that's something that the community needs to take as feedback and consider a bit, and have an introspection.
Okay, quick question. So you refer to usability, let's say, of semantic web standards and datasets. So actually, that's my question. Are you talking about the vocabularies, or are you talking about the datasets, or both, maybe?
I'm talking about the content that the developers of linked data put in the linked data. So let's take, for example, RDF, right? RDF defines some very nice predefined elements, like the subclass taxonomy, right? The subclass relation, or the labeling relation for lexicalizing entities. There are these things, and actually this is supposed to be, this is meant to be, let's say, a nice feature that other technologies don't have. So a property graph, like a technology like Neo4j, doesn't have a schema, doesn't have these predefined elements. And what RDF is selling is that, look, by predefining these elements and agreeing everyone that they have this particular meaning, which then we can use, as Katariina said, for reasoning, we can have nice behavior. The thing is that when the input to this, when the subclass relation in RDF doesn't really reflect the subclass relation, content-wise, or the labels that we have for entities are not really synonyms to each other as in theory they should be, right? We end up with problematic reasoning. And this is expected to happen because conceptual modeling, semantic modeling is really hard, right? It's about agreement. More than technology, it's about agreement. It's all of us together, for example, in a given scope, we have to agree on the meaning of things. And agreeing on the meaning of things is really
famously hard.
Exactly.
Yeah.
So if we kind of get this, like what you're saying, Panos, about the kind of difficulties when you have a lot of things out there. So we're at the timeline where we discuss what's before 2001, when that famous Tim Berners-Lee, Jim Hendler, Ora Lassila Semantic Web article came out, and maybe the next in that timeline, I mean, then there's RDF descriptions of getting those standards up, like that will follow as you said. But then we probably hit the first like milestone, which had exactly these difficulties as you described, which is the linked open data. So that promise, I remember that was when I was a researcher in the semantic community. The EU was putting a lot of money into it. We had so much research into it, and we're like linked open data cloud, and applications on top of it, and there was a big hype. And I remember retreating to the arts because I felt that that bubble was about to burst. So I retreated for 5 years doing something slightly different. But I felt that was like around 2008, 2007, that time, around 2010s.
Even let me
like that point in timeline as well.
Let me give an example here, right? Even not with open data, even with closed data. So let's say that IKEA, where Katariina works, has its knowledge graph, right? And tomorrow it acquires another warehouse company that has its own knowledge graph. And let's assume also that both these graphs are implemented in RDF, right? Using and we also assume that they have the best ontologies available every company. Still, after the acquisition, if the two teams that have the two knowledge graphs decide to say, okay, let's map them together, let's merge them, my bet is that it will be at least a 1 year project. It will be an expensive work. It will be worthwhile, but it will be expensive. It will not be a simple thing like let's do it it will be done in a month or so. That's
Panos, but if you compare that, if they were not having RDF and have to do the same task, then I think we are talking about completely different magnitude of.
I completely agree. I agree. So I'm not saying RDF is useless in that sense, or it's really a step forward. I'm just saying that we are not yet at the stage of being able to have large-scale interoperability, especially in the web. And RDF is one foundation, but we need to work further. And working further should be on one direction, should be on making the semantics even clearer, and even working towards the content. In a similar way that, in the machine learning community, after building all these fancy algorithms, they are now coming back to say our data are problematic.
Right.
Okay? Yeah.
We have
that same. Oh. Go
I
ahead.
was just going to say we have a question from the audience. So someone is asking if all knowledge graphs are based on an ontology model.
So I answered in the chat a little bit, but no,
Okay.
not all knowledge graphs are built off of an ontology. Most graphs have to have some kind of model because you have to relate two things together and you have to know what they are. But ontologies normally are reserved for, these triple stores that are usually RDF or versions of RDF type triple store things based. But with labeled property graph, you have some kind of model behind the scenes. It's not usually an ontology though.
Okay, that's a perfect segue to, sorry, Panos, you wanted to say something, but I was
Yes.
just going to say that since we already mentioned a couple of times actually already, RDF and knowledge and, property graphs, it's a great segue to go to the next subdomain, so graph databases, because those are the two key models. But I'll let you finish what you wanted to say, and then we can talk about that as well.
I wanted to say that this is something that I don't agree, that you cannot tie a term like ontology to RDF or to a particular implementation, right? An ontology, we see the definition is a conceptual model. It's a conceptualization of, right? If we take the very first definition of Gruber or even of Aristotle. So, it's like, for me, it's like hijacking the terminology and the lexicon, that ontologies are always RDF. It's not correct. They have differences.
So
right?
I think that the terminology is what you're saying. When you say ontology, you're right. It's a model. And that's why I said that most of the time there's some kind of model behind both. But when people talk about ontologies, and I would love to hear if people have heard it related to something other than RDF, because I really don't hear that very often.
Yeah, I would agree as well. It's definitely the class and property definition part of RDF. And then it even excludes, by some more stricter definitions, instance data and data graphs. But obviously,
thing, like, how is that any different than a node and edge? And that's what labeled property graph uses. It's almost the same thing. It's just the different levels of abstraction that we're talking about.
Yeah, it's about having some predefined construct, some predefined element. So the node and the edge is similar to, in RDF, to the entity and the relation, then the predicate, let's say, and the subject object. It's just that RDF comes and says, okay, we also do a separation between classes and instances, an explicit one, in addition to. George, I think you want to go to the next.
I was just going to say that we've been actually we spent quite some time on the semantic web part, which is interesting. It always seems to be controversial in a way and sparking conversation. But just to move the discussion to end the timeline as well to the next stop, let's say. So fine, we have all these graphs, whether they're RDF graphs or property graphs, and you need to store them somewhere, obviously, and this is the part where graph databases come into play. And I would say that historically, in my view at least, the birth of graph databases was pretty much coincides with the birth of the semantic web, because the first graph databases were triple stores, RDF stores, and then eventually property graphs came along as well. And so, now we have this big tent of graph databases with a very, very big number of vendors, actually, remarkably big for one technology. And we have those two camps, let's say, RDF and property graph. So you already started touching upon those two representations. So I'll just let you continue. I just wanted to introduce, the next stop in the timeline, basically.
I also share a chart. I don't know if you see that, but
we briefly saw it. You can share it again, because I think it's off screen now.
Yeah. So yesterday we published the new version of the latest version of the Web Almanac on structured data, and so this is probably the most comprehensive list of analysis of website for structured data. And it's surprising to see that after so many years, the most popular format remains RDFA. And this kind of gives us an idea also of how this evolution from, the semantic web, or even before the XPath system, and then semantic web, and then the linked open data movement, and then now, the knowledge graph, and it's kind of leaving its trace on this public web, and we're creating a very large open graph that is accessible to anyone. And here it's a list of 13 million websites. But it's interesting to see how we got far with this idea of kind of moving from the web pages to the web of data. So that's one of the chart that I have for you, and I have another one that we are about to publish tomorrow, but we can use it later.
Yeah, it is interesting to see that. Yeah, after all this time, RDFA still is the most widespread.
It has to do with kind of legacy CMSs using it, like the Drupals and the templating. I mean, when we think about these technologies applied to web scale, then of course there is a digital footprint that it's left behind by technologies that don't get updated or get slowly updated. And this is quite evident in this report, because we can see construct like friend of a friend that have been used, in the early days, that are still present because they are kind of encoded in so many static templates, and it's really fun to see how we're going. But it's interesting because we can also see that whether, of course, this is a representation of the public data and the structured data, that it's primarily driven by, of course, the web search engine, we can start to see arising, more and more publisher using this data way beyond SEO. So, the bio schema, or, specific verticals in the automotive, where a search engine would only grasp a fraction of the amount of data that gets published.
Andrea, I shared the link in the chat, which is from the last year Common Crawl Corpus, and it gives different ranking of the available data.
Right.
On the web. In it, RDFA is not top and not second even.
Right. So the way in which the data has been sampled is different in these two data sets. The web archive, it's basically analyzing the home page, which of course provides some limitation in terms of the understanding of the formats. So it's a wide different type of data set. I was also surprised to see that difference. But then thinking about the way in which the data is sampled, so which is looking at the home page, and there are a lot of these legacy system there. It would make sense to see RDFA as a predominant format.
I don't know. Apart from this Common Crawl Corpus, whenever I grow something from the web, I find much more JSON-LD.
Yeah, of course, it's
micro.
It is growing very fast. I mean, in this sample, JSON-LD got to the 32% of the entire data set, which is pretty huge compared to what it was last year. So definitely, and also in terms of usage and interoperability, everyone is looking at JSON-LD, and no one is probably looking at RDFA. Also because RDFA is used for, as I said, these very kind of static descriptive properties. Whether in the case of JSON-LD, we can finally start to see graph or small graph emerging. Let me share that too.
Yeah, JSON-LD is great, but in many applications, you would need to intertwine data with HTML. Well, JSON-LD is basically disconnected from the HTML, and that, in some cases, is problematic. There was such a case with RDFA text editor that when trying to do that with JSON-LD, that's really difficult or borderline impossible.
Yeah.
Just to add to that, Ivo, since we're theoretically at least talking about graph databases, I've also seen some graph databases starting to support JSON-LD out of the box lately.
Yeah. I mean, it's becoming more common. Of course, for us, it's kind of a native language. Doing SEO. So here it's it's interesting because we can see the chains of entities and the relationship among these entities and how they are distributed. And from this chart, we can see the different sectors behind this data. So the generic publishing, with generic properties such as web page, and then it's, kind of the blog posting, the article, and then of course the e-commerce side. So the product classes and the offer, and then as we kind of go down, we can start to see the local businesses, and then the automotive sector, the software industry. So it's kind of becoming quite a large amount of data from different verticals, which, I mean, in my opinion, it is the semantic web as it was originally designed, that it's happening. And we currently have search engine that are using it the most, and people are looking from, kind of the search engine perspective in the first place. But there is so much more that can be done on top of this data that we're just at the beginning of it.
Okay.
Just one comment for what George said. Indeed, it's happening with JSON-LD, but here is also important to know the difference between RDF and LPG. It's not only in the format, in the way data is structured, but they're different species altogether, because RDF is a conceptual graph with, while LPG is particular to graph databases. In that sense, you can have RDF with document database, on GraphDB, on SQL, or on triple stores and quad stores. And the same with JSON-LD. Maybe there is a way now to handle it in a database, but there are plenty of implementations where JSON-LD is managed by MongoDB, Elasticsearch, or just a simple file server.
Yeah, sure. Yeah, indeed.
And let's not forget, you don't have to pick either or. I mean, you can use a label property graph and a triple store. They do work together. It's not something that you have to pick a camp.
Yeah, I remember when I did actually, I'm really naughty because I just use Neo4j for visualization sometimes, because it's just really quick, and I have my own scripts to kind of just pull it out, and I like it best. And I had it in a blog post for the actual work I did in RDF, but I was just using Neo4j visualization. And I remember getting hate mail of sorts of like, why aren't you using W3 stack? Like proper people, like, or which is the right stack? And I was like, come on, it is not either or, it's both and more. It's there's some like amazing graph analytics things that you cannot even do with a triple store. Like we had these great graph scientists or like data scientists who were, for them the length of a path was really important, either to input or to then get as an output from any kind of query, and that's just not supported by Sparkle. And that's why there's even, you cannot do like everything with either or. So use both for whatever, and work with them interchangeably. I think a knowledge graph in itself is not an RDF text file. A knowledge graph is so much more. Somebody in the chat already was saying that it's basically instantiating from the ontology, like taking the ontology and then like adding the muscle and the fat around the skeleton. But then a knowledge graph can even be even more, and very many different kind of systems. And I think that's when we're having in this like connected data world, we're going to discuss also enterprise knowledge graphs. And I'm always saying, it's probably 10% of writing RDF. And then the work to create a knowledge graph is so much more. It's because there's also that thing that we were talking about, which I think, Panos, you were also kind of referring to, which is the shared conceptualization. And whereas we have graph databases and we have our standards, we haven't really we don't even have that many tools as you would expect for creating the shared understanding between humans and supporting the dialogue and, building a graph in a community way. Like that tooling kind of doesn't exist, or it exists to some extent in like enabling commenting for triples or something like that, like in just little bits and pieces. And then if you're building an enterprise knowledge graph, most of these enterprises are not dictatorships where everything is centralized, but they are kind of like scattered around, tools are scattered around, and how to then create that shared conceptualization in those tools. That's, I think, even the bigger question.
So one thing I have been involved in is Carnegie Mellon University has something that they are working on to actually facilitate some of that. It's going to be similar to human in the loop machine learning kind of review of training sets, but more on the triple and graph side. So I've been actually working with them on like, what does an interface look like for non-graph people to be able to interact with these things to help refine what we all have in our knowledge graph. So I would encourage you all to go and check out what they're working on, because it's pretty cool.
Nice.
If I may offer perspective here, because so a text kernel, the knowledge graph that we have been building when I joined the company, we started building, is completely a label property graph. So it's Neo4j. And even though when I came to the company, I mean, if I had the chance, I would probably do it in RDF. I found some situation already there, some existing initiatives which made us create property graphs. So what I realized from this experience is the following. There is when it comes to building knowledge graphs, there is the perspective of the modeler, of the conceptual modeler, who thinks in terms of concept entities without caring about, how the things under the hood work. And there is the perspective of the engineer who needs to run the queries to run fast, right? Or the algorithms on top to be able to run fast. These are two perspectives, and for me, the debate about triple stores versus one part of the debate between triple stores and property graphs, graph database, this kind of graph databases, is related to the engineering aspect. So which queries run faster, which are not, right? What can you run, and what are the pros and cons of each? Conceptually wise, what the additional difficulty that I had in my team to do was that I didn't have what RDF already provides. I didn't have the subclass things. I didn't have the class versus individual. I didn't have the labels. I didn't have all these predefined elements. So I had to define them from scratch and in an ad hoc way. So for example, in Neo4j, when I want to relate for an entity its labels, I don't have RDFS label. I have just an edge, which I call label, and this relates to another edge, which I call lexical term. The problem with the limitation of that is that if I want to publish my knowledge graph to the web so that others use it, they will really have to follow to read the API. It's not as straightforward as it could be with RDF. But if, and this is the case at TextKernel, we don't care to do that because we provide our knowledge graph through a dedicated API and usually within products, this is not a requirement. So in that sense, for the scope of the company, an LPG works fine. So it has to do a lot. It has to do a lot with the scope of interoperability that you want, and this is a factor where RDF is better than a property graph, conceptually wise. Engineering wise, I don't have an opinion because I haven't really run any benchmarks, but I guess you have other people who are more expert in that, and they can, they have compared, for example, how fast a query runs in a triple store and how fast it runs in a graph database.
So I have a rule of thumb here that I use for when to pick a triple store and when to pick an LPG, and I would like to like run it by you. What do you think about this rule of thumb? So the idea is, if I need to define an ontology with the classes and properties, have those few hundred concepts, maybe I will also have their few taxonomies to really get like to populate in a kind of controlled way, or have a controlled vocabulary to share in the organization. I would do that in RDF, and I would store it in a triple store. Actually, I would store it in a repository from where I would push it to my triple store, so that it's also readable as file. But then if I have a data graph of sorts, let's say as I work in e-commerce, all the products that are sold by it, where you have many kinds of, in the IKEA context, many kinds of chairs and things to sit on, and many kinds of tables, etc. And they're all repeating their variations of each other, like color and size. That I would push those individuals, each product, I would push into an LPG, because then if I need to calculate graph similarity, I think LPG would be much more applicable for that. I think those calculations and those different algorithms would work better in an LPG.
Yeah, Katariina, I use a very similar approach. So it's so funny to hear you say that, because it validates what I do, which is great. I usually use a similar rule of thumb where, so first, I'm not using enterprise. I'm actually, it's a product, it's a search engine for customers that I'm working on. So my, source of truth, where all of the nitty gritty data and all that modeling and inferencing happens, that is what I use my RDF for. But then when I need to push it up into a data visualization where I just need to show how two concepts are related to one another in a user-friendly way, that's where I use my label property graph, because it can do those quick calculations without having to go to the root source of all the other data I have in my triple store.
Just to add to that, because that's a point that Katariina also made previously. Actually, that's kind of changing, and it's very recent to me, because, like I said, I just finished doing this research on the capabilities of different databases. So RDF stores are nowadays also adding graph algorithms, basically. So depending on the algorithm you're interested in, your RDF store may be able to give that to you out of the box.
Yeah, that's what also my experience, which is somehow limited, but we always see that this graph data in RDF, it's the foundation, so we agree on that. But then if you need to compute it, then you can create vectors out of that and work with these vectors, or even getting the data straight into a search index could be a way of making the data in the backend accessible without going through the property graphs. But that's our limited experience, because of course we are mostly focusing, of course, publishing the data so that the search engine can see it rather than using the data. But when we have to use the data, creating the vectors out of this data, it makes it very practical to, calculate the similarity, the distance, or recommend, one product from another.
Well, and that's another piece that looking at performance, the performance between a triple store and a property graph used to be a
very
desert,
different, yeah,
right? But now, I was doing some testing. Yeah, the olden days. Now doing testing between like Neo4j. I did one for Neo4j. I did one for GraphDB and Stardog. GraphDB and Stardog basically are almost the same performance, which is great. You don't necessarily have to pick because of performance anymore. You can pick for your use case.
Yeah. Also, the output of these systems now include the support for GraphQL, which makes it very easy to consume the data on the front end without going through too many steps, which also I find it practical. So I believe that this distance between the two platforms, it's kind of narrowing down, and AI models being trained on top of the graph, it's becoming kind of the source of truth when you need to compute it. rather than the property graph. But
great. So actually, we already kind of tiptoed, let's say, around knowledge graphs and what is a knowledge graph. And well, somebody gave definition of sorts. Well, first of all, there's tons of definitions going around. Some of them, very elaborate, very good. But my personal favorite, let's say, is the simple one that I think somebody also shared already. So a populated ontology. But again, I think we've kind of talked about it. So what is a knowledge graph and so on. And Andrea, you also touched on the last, let's say, subdomain of connected data. So graph machine learning and graph AI, let's say. And I think you're probably definitely, compared to me, the most qualified person to talk about that subdomain here.
Yeah, so let me share again my screen, because the only way that I can talk about stuff is by going through examples. So I'm just gonna share a little bit of another practical use case that we were working on in these context. So let me go grab the screen here. So. So here we have a three-dimensional representation of an RDF graph that it's behind our blog. So something very, very simple. And here we can see, for instance, the entity for connected data, because of course we blog about connected data. And here we can see that I can quickly compute the closest entities in this graph, and this is made possible because I have used TensorFlow to train a model that uses the statement in the RDF graph to learn what is truth and what is not, and also to provide this representation of the multi-dimension of an entity like connected data. And here of course we can see the entities that are related to the event within the context of our editorial plan and team. So this is one of the very basic example of how we can get the data into deep learning and then consume it by making inferences that don't even go through a query in the traditional sense, but use machine learning for predicting new facts or discovering new stuff. And this is also what we're doing with the multi-modal search. Again, it's getting the data from the graph into vectors and then consuming the vectors for whatever application you have.
Mm-hmm. Right. That's one way. One additional fact, let's say, to point out about graph machine learning is, well, precise the fact that traditional, let's say, machine learning mostly works with tables, with matrices. And graph machine learning also makes use of the connection. So that's why it's also called
beauty.
Yeah, exactly. Why it's also called geometrical machine learning sometimes. So it's kind of 3D, let's say, if you can imagine it in such a way. So I've also heard some people make the claim that because of that, well, you're basically able to model more information and more features. And they say that, well, pretty soon the best machine learning models are going to be graph-based ones.
Well, I mean, in this example that I show you, we are training the model with the edges. So the relationship are playing the role, and that allows me to make a prediction based on the relationship, which it would be otherwise impossible if I wouldn't have the graph structure in the beginning. And that's one of the advantage. The other advantage, of course, is the possibility of explaining why the model is reacting in a certain way, because I can get back in the data and understand the semantics of the data, which of course from a flat table would be missed. And this is also particularly helpful when we start to use these data set for for instance, generating text, because I can get back to the semantics of the graph and verify the validity of the text, because I do have the semantics, which otherwise would be missing. So there is a lot of advantage in kind of moving into deep learning with a graph in the back end.
All right.
And Andrea, how would you say, how well is the model learning the difference between like semantic nuances of the different kinds of connections? Because normally you would, I mean, you have, I put them coarsely into two categories. You have structural connections, which is all about subclass of instances, part whole relationship, those
Yep.
kind of things. So you know they kind of belong together. And then you have the associations. And sometimes an association can be like a negative connotation, and sometimes an association can be like a strengthening. So how is that picked up?
So depending on the type of data, we want to make sure that the model is capable of predicting true facts. And the way in which the validation occurs is that we will start to create a toxic statement to validate if the model is getting it right or not. And when doing so, we will tend to filter a proper relationship between two different entities rather than the property link between the attributes of the same entity, which are of course less interesting in the use case that we're looking here, where we want to recommend similar content or find topical hubs for a website to create pages. So one important aspect is focusing on a set of relationships that are bringing the meaning that it's helpful for the use case.
Yeah, I take that same approach, Andrea. I'm also working on recommendations and finding things within full text that is helpful for the user. And normally we're focusing on the positives or things that are going to answer a question. So we derive the questions from our search logs, and then we find through full text mining what is going to answer that. And those are relationships in and of themselves, which our users find very helpful.
Yeah.
Okay, cool. So I think we've more than covered actually what connected data is about, and we even expanded to many different directions, and it's been very interesting. But wearing my moderator hat here, I think it's time to move on to the next part of the conversation, which is what we are actually going to see in connected data world this year. So for that, to have like a shared program, let's say, with everyone, I just typed in the chat box the schedule for the event, for which actually this is the first part. So we start today with this conversation, and people attending can get a pretty good idea of how our workshops look like, because that's the main concept for workshop. You have a group of experts discussing a topic and taking questions from the audience. Somebody's moderating. It's pretty familiar actually. It's something we all know, I guess. Tomorrow, however, we have the second part of our pre-events, which is we're opening our virtual venue. So this platform or other platforms like this work pretty well for that type of setting. However, you don't get the serendipity that you get in real life events through that. You need someone to operate it, and then, best case, you get like some breakout rooms, and again, somebody needs to take you and put you in that breakout room, and then somebody needs to. It's kind of clunky, let's say. So the best way we found to deal with that clunkiness is to have something that replicates the real world as close as possible. And we're using a platform called GatherTown, and our virtual center is called Connected Data World Center. Well, not very originally, but quite on brand, let's say. And we're opening it up tomorrow. And so what we're going to do is that, as some of you may recall, last year we also had, like every year we have an event, but last year was also virtual. So we've taken all the recordings from the presentations from last year, and we're doing replays in the virtual center tomorrow. So it's going to be open. The program is going to be the same as it was last year. So we open at 8:45 a.m. GMT. And, you have the regular routine, welcome address, then a couple of keynotes, then different tracks. So you're going to be able to watch all the talks from last year. And we're also going to have some live sessions. One of them actually may be interesting to you, Panos, because it's going to be about an effort one of our team members is doing to build a labor knowledge graph. So he started that as a kind of pet project, let's say, and pretty soon he ran into a number of issues, like with vocabularies and how to align them and how to populate them, and some knowledge graph specific issues, and some other issues that are project related, let's say. So how to manage contributions, where to go with that. So we thought, okay, let's have a discussion about that. So that's planned for 1 p.m. GMT tomorrow. That's going to be a live discussion in the virtual venue. And we also have another live part, which is at 8 p.m. GMT. So for that, we're going to show how things are going to work in the actual event. So besides the pre-recorded talks that you're going to be able to watch all day, in the actual event on December 3, on Presentations Day, also we're going to have the presenters in live attendance. That means that, sure, we're going to show the presentations, but of course, after that, people will be there for Q&A. And you're also going to be able to do what's one of our favorite things to do in real life events. So follow, chase down speakers to the lobby and hang around with other people and do all of that nice stuff. So for a preview of that, join the grand opening of our virtual venue tomorrow. So with that said, we can move to what the program for the actual event looks like. So it's December 1st, December 2nd, and December 3rd. On December 1st, we have a number of workshops. So some of you are involved in workshops. So I'm looking at, I guess Katariina and Ashleigh and Ivo and Andrea, you all have workshops that you are involved in. So the natural thing to do would be, I guess, to ask you to talk about what you know best, which is the workshops that you're involved in. So who wants to go first?
I suppose I can kick off. Me and Katariina and at least one other person are going to be talking about how to create community with folks that are in your organization or even outside of your organization for, anybody that feels like they might be on an island. I think there's a lot of us, especially in Graph, since it's kind of like the oddball thing that people work on sometimes at an organization. So we're going to be talking about some of the things that different groups struggle with and how to find others that are like-minded with yourself so that you can feel like you belong in a community of Graph professionals.
Cool. Let me just, be the pedantic guy here and say that, well, yes, you are going to do it, and it's going to be great, and I definitely want to attend. But actually, that's going to be on December 3rd, so it's going to be hosted in the virtual venue. On December 1, well, the setting will be like the one we have here, so live webinar platform and panel and all of that stuff. So maybe I'm going to ask Katariina to talk about her workshop with Michael Ashhold and a number of other people.
Yes, and actually, I think Ashleigh is I'm also really burning for the December 3rd one as well. But we're also with Ashleigh on the December 1st one. So probably that's the kind of confusion, and the knowledge, and the topic is knowledge graphs in the enterprise, what you need to know. And idea is really, what does it take to build an enterprise knowledge graph? What kind of roles does it entail? The common question I get a lot is, what kind of team do you build? What kind of, who should I hire? If I want a knowledge graph, what next? And it's drawing up on a lot of experience. We have here great practitioners, also colleagues from Semantic Arts joining us, which is a company that consults in starting an enterprise knowledge graph. So that experience with consultancy companies is they've seen a lot of cases. I'm really looking forward to concrete examples, concrete problems, and things that we couldn't think of when we were like just learning about RDF and knowledge graph, but actually what it takes, the sweat and the tears that it takes to build an enterprise knowledge graph.
Great. Yeah. It's I'm really looking forward to that. And yeah, as you said, well, the two of you are going to be sitting in that one. There's going to be Michael Ashleigh from Semantic Arts, and we're also going to be you're also going to be joined by Michael Atkin, who was one of the founders of the Enterprise Knowledge Graph Foundation, and now he's pursuing some other interests with the new consulting company that he has. But he also had like a huge experience in helping enterprises building and knowledge graph. So
it's always a pleasure talking with Mike as well, because he's also found this like way to structure the aspect of enterprise knowledge graph to management. Especially, I find that he kind of finds that wording, and it's exactly what he's working with. And I think that's going to be one topic as well, is if you want to build an enterprise knowledge graph, you have to get management on your board, because this is not going to be a new fancy application that immediately gets you a lot of money, but it's going to be an investment in infrastructure. And that's that nature then gives you certain challenges.
Yeah. As previously mentioned in the semantic interoperability part, well, some of those things are really intangibles, but well, they're actually at least as important, if not more important, than the technological aspect. So going from knowledge graphs to something, well, a bit more unusual, and it's actually one of my favorite topics. We are sitting together in a workshop with Ivo, and this one, as opposed to enterprise knowledge graphs, is about personal knowledge graphs, and it's a concept that perhaps not many people are as familiar with as enterprise knowledge graphs, but we're starting to see that happening as well. Or so far, maybe not in such an organized or widespread way, but at least, I'm an enthusiast, and I know Ivo is one as well. So we're starting that technology. We're starting to see that technology being adopted by not just companies and organizations, but also individuals. And that's a kind of natural consequence, let's say, coming from the fact that, well, the amount of information that we all have to deal with now is kind of multiplied to a level that, if you don't apply some kind of method and some kind of technological aid, let's say, to that, you can very, very soon lose control. But, well, Ivo, I'll just let you say a few words about that, because I know that you are one of the leaders in this area, let's say, and you're doing some very advanced things.
Yeah, well, basically, my favorite topic is actually enterprise knowledge graph, and I'll be very much looking forward to this event that will be there. And I could say that there was not much talk about enterprise knowledge graphs in the last, in the last 3 years there's a lot, but previously there was almost none. And I'm happy that this is happening more and more. That is not the case with personal knowledge graphs, which is another very dear to me topic and practice. I'm doing that for quite a while. And I think it's following up. Then there was a workshop at the Knowledge Graph Conference. There was another workshop, academic one, organized by Paramita Mirci and a few other people. She would also be in that panel on the 1st of December. And, well, things are coming from different directions. The attention to personal knowledge from the regulatory perspective, from the work on solid and similar decentralized initiatives. And somehow the whole Corona situation accelerated this very much in terms of tools for productivity and for research that manage data as personal knowledge graphs. There was an eruption of those tools. I think there were none or a few just 3-4 years ago, and now there are over 50. And new ones are popping out all the time. And they're also evolving from really personal knowledge graphs to collaborative knowledge graphs.
Mm-hmm.
So that's a very interesting area. I personally believe also that for enterprises, there are so many people that when they need to have a decision on something related to enterprise knowledge graphs as an approach to integrating different things, they cannot do that because they have no daily experience with knowledge graphs. And if they start managing their personal information as knowledge graphs, I think they would look differently also at enterprise knowledge graphs when they see what they can do with different silos that they have in their world, documents, email, bookmarks, and highlights, and everything. So we're going to have this talk with Jerry Michalski, Paramita Mitza, Alan Morrison, and Jeff Tang on 1st of December. There are no actually talks apart from this panel in this conference, and I hope in the next editions it will start to grow and be as visible as enterprise knowledge graphs.
Yeah, it's an emerging area, and one that I would say in some ways has its roots in, as you also said, like personal productivity tools or note-taking tools and so on. So for a long time, people have been using the traditional, let's say, the legacy systems in that area, and they're starting, many of them at least, are starting to realize that they're kind of restrictive in some ways. So as you said, there's like many new tools that are popping up, and some of them, to some extent at least, are trying to support the graph element behind that, and semantics at least to some extent, and so on. It's an emerging area, and yeah, I think we have some of the best people around to highlight it. And just so before we go, there's actually a question from someone again in the chat who's asking what's the difference between a personal knowledge graph and an enterprise knowledge graph. And I'll venture my own answer, and feel free to jump in as you see fit as well. I would say that you actually kind of touched upon it in your previous in what you said previously. So a personal knowledge graph is something that you organize for your own needs. Basically, you may or may not have a specific vocabulary. You choose the tools. There's not much of an interoperability issue for that reason. For an enterprise knowledge graphs, there's different ways to arrive at enterprise knowledge graphs, and I think Katariina and Ashleigh also kind of touched upon it previously. So usually it's not like a dictatorship top-down thing. You have to compromise the needs of many departments, many people, and many use cases as well. So actually coming from a personal knowledge graph and trying to bring them all together may be one way to arrive at enterprise knowledge graphs.
Yeah, well, enterprise knowledge graphs, they appear, and please, Katariina and Ashleigh, correct me if I'm wrong, in two situations. One is you would like to integrate data from heterogeneous sources, and they could be SQL databases, text and XML and JSON files, and you have sort of a semantic layer that is enterprise knowledge graph. And the second is, in enterprise settings, you have a task that for each other data approaches are not so good. That's why you go and do it from the scratch with enterprise knowledge graph. I think these are the two main big use cases. They're actually packages of use cases, not just doing that would also change the paradigm of how we do IT. Normally, the IT is you have requirements, historical requirements with which your solution answers. While knowledge graphs, they open for the unknown case for something that might change, and their flexibility is what drives their adoption.
Mm-hmm. Right. So again, quick reply to a quick question from someone on the chat. Would you say Obsidian, yes, absolutely. Yeah, it is one of those tools. And well, like you said,
the interesting thing about tools like Obsidian is they are in a way also data-centric. Because in fact, you can have your data is entirely markdown. You can just start using something in Obsidian. You can continue with log-seq4 or Dendron, other similar tools that would work with the same kind of thing. And I think that's an important trend to decouple the data from application. That is particularly visible in the personal knowledge graphs where personal data is personal and you don't want to really expose it.
Mm-hmm.
If I may be a little bit philosophical also in this question about enterprise and then personal knowledge graphs, if you look at how work life is changing, it is changing so slowly from, I mean, it's not a Taylorist hierarchical society anymore, or it well depends on the company, but at least a knowledge intensive work is already looser, and there's even like talks about flat hierarchy, and there's everything in between what it actually is. But the future of work is a network of most likely self-employed freelancers exchanging their works for companies. Like that's already in any HR talk you're sitting in an enterprise, they're talking about this future that it's coming, and that people don't really want work contracts anymore. They rather want like from their own work from their own company to another bigger company, and that kind of exchange. So if we look into the future, this is need to be like what is happening is that an enterprise's know-how might actually get scattered across personal knowledge graphs. Like that network of those personal knowledge graphs might be actually forming the enterprise knowledge graphs. Why am I saying this? It's kind of, even when I say it out loud, it kind of feels weird, but I think that's where it's going, because every time I build an enterprise knowledge graph, HR comes knocking and say they want something similar. They want to capture the skills and the know-how. They want people in the company need to know who they need to contact and who to talk to. So that need of a network of personal knowledge graphs already exists in an enterprise. And I think that trend is just going to become stronger.
Yeah, NASA has one. David Meza is somebody probably all have come across his stuff. He's very well known in the knowledge graph space. That is his whole job at NASA is creating that, and he uses Neo4j for it. But that doesn't mean that's the personal knowledge graph tool of choice. But yeah, I think that even apart from the things that Katariina was talking about, if you are working in a organization where you have a lot of development teams and you need to bring a new team together to develop something, having a personal knowledge graph sort of like this, where you can draw different skill sets that you didn't realize according to what somebody's job title is incredibly important, so that you can use the people you have and not have to go and contract always for people.
I like a lot this idea. So what is the personal knowledge graph tool that I need to start using, Ivo or George? I like a lot this kind of vision that Katariina has projected of this blend between the enterprise and the personal as kind of the evolution of the workforce. It's kind of demanding this blend to happen. And also the second, so the first question is very practical, and is what tools should I use? And then the second one is not philosophical, is again technological, is where does Solid stand in between? Or I mean, how is there a connection with Solid when we talk about personal knowledge graph? Because I'm very interested.
Well, I will say one thing on Solid, because it bothers me, is I have a beef with it. It is not easy for anyone that doesn't do graph to understand it, which I think is a huge blocker. So if anyone knows people working on it, please help them with that.
We do know some people, but
okay.
Yeah, I was going to say something similar as well. So yeah, in theory, Solid is very relevant to this topic. In practice, however, it's not very easy to use. I mean, I confess, for me, it's not very easy to use. I don't know, maybe it is for others, but not for me. So I'll give you my personal take on what I use basically.
Right.
I'm an Obsidian user and fan. I like the fact that it has what I call like the least common denominator, so it uses markup. However, there's the downside of that. So with markup, you don't have semantics, and that's a big pain. So you also don't have interoperability with other tools because, well, other tools are using Markdown as well. But yeah, it has its own flavor, so it's not, you can't just easily switch.
And can I export the data into my WordLift RDF pipeline, or how do I do this thing that Katariina is telling me to do? That I want to bring the data of the people into the big graph.
With Obsidian, I'm not sure if or how you can do it. There's other tools that there's.
I watched a video of Ivo a while ago. I was kind of going through that. What was that, Ivo?
Yeah, well, first let me go a step back to mention something important from the technological perspective that the personal knowledge graph tools are bringing. And because we talk technology-wise that we have RDF and LPG,
right?
And from over 50 personal knowledge graph or just having something to do with that tools, I know only one that is using in some way RDF and only one that is using in some way LPG. The rest are doing graphs in novel ways, which I find exciting. So this duopoly, LPG and RDF, is breaking slowly. Then, in terms of usage, it really depends what you would like to achieve. I personally use several tools currently. I can explain why I use several tools. I started. I'm an early adopter of Rome research, which is quite powerful.
I love the approach and the interface of that. that was one of my options. Yes.
So what it has nice is, apart from the standard query language, there is also this data log possibility for querying, which is extremely powerful.
Mm-hmm.
And then there are a lot of really nice features and a lot of extensions that you can do wonderful things. But there's a lot of things that are disturbing. One of it is the security. The other is scalability. Big graphs become a bit slow because everything goes to the client memory, and maybe the way it's managed, it's something. So in the third maybe dimension is that publishing is not so easy. You need additional things to do just publishing from your graph, which is, I find, important. Yeah. And maybe the last drawback is that it's not really data centric. I would prefer that I can read my graph with any other tool, not to be locked in one application. Of course. And for all these other use cases, I use other tools like Logseq, and there is another Rome-like tool, again written in Clojure, Athens, which promises serious collaborative features to bring, and also it promises to bring semantics and some kind of RDF-based features. They started partnering, I think, with Phare. That would bring, also in terms of scalability, they promise interesting things because they would like to spread the load between client and server when things scale up.
So if I understand correctly,
we'll come and talk about it.
We don't have yet collaborative support, or I mean, it's not yet.
This is the direction Athens Research wants to take, and actually their specific take is from personal knowledge graphs to collaborative knowledge graphs.
Okay, because that's pretty important aspect. And then the other one is that everyone agrees that we need solid in between, but everyone agrees that it's not usable at the moment. Because I mean that's exactly a use case for solid. I mean the moving the data back and forth from kind of the private cloud into a shared cloud, it would be a perfect scenario for that.
Yeah.
You didn't manage to invite Tim Berners-Lee, George.
Now, to be fair, Rome Research is already collaborative for maybe over a year, and but not in a way that it can really support various cases of collaboration.
Okay. So yeah, apparently personal knowledge graphs are
a big topic.
Are a thing, at least for this group. So before we move to the masterclasses, in which I'm going to ask Panos to talk a little bit about his masterclass, Andrea, would you like to say a few words about your workshop, because you also have one?
Right. So our workshop is going to be about building a multi-modal search for an e-commerce site. So the use case is as simple as a product knowledge graph from a small fashion e-commerce site, and how these graph data can be fed into a multi-modal search, which means basically a search engine that is capable of dealing with both images and text at the same time in various form. And we're going to work with GenAI, that is an open source framework for neural search that we've been partnering with. And so we're going to kind of dive deep. It's an hands-on, very practical approach to see what can be done and what are the challenges, and how we're trying to get it to the, in the hands of users we are targeting next year to be ready for WooCommerce e-commerce stores. So we're going to start with the long tail, but of course we have other use cases. So that's going to be the workshop.
Okay, cool. Let me just quickly mention the other workshops that we have on the 1st of December. So we have a few, actually. We have one on graph machine learning, which we briefly mentioned earlier, and we have some of the top experts on that, actually, so that's going to be a good one. We also mentioned reasoning, so we also have a workshop on reasoning, the momentum behind semantic reasoning. And we have one of our other panel members, Raafat, moderating that one. We also have one on the connection between connected data and sustainability, and that one is organized and moderated by my co-founder in Connected Data World, James Phare, who works in sustainability and also uses connected data technology. So he's the right person to talk about that, and he also has some people with deep expertise and experience in that. Something a bit more exotic. So we also have a workshop on hardware, actually, on novel AI hardware architectures for graph processing. So since in the last few years we are seeing a number of innovative hardware designs popping up, many of them have one thing in common. They're actually built in a way around the notion of processing graphs. So we have a few of those innovators gathered together, and one of my colleagues on ZDNet moderating that, Tiernan Ray, who's actually one of the experts in AI hardware. So that's going to be one to keep an eye on. And Andrea already spoke about his workshop, and we also talked about the workshop on enterprise knowledge graphs. We have one different angle, so investing in connected data. That's something that I don't think I've seen many people talk about. So this whole technological area is kind of exploding, and there are many reports that are stating, that the market is growing. And I guess this is something that intuitively all of us can attest to. Like, there's more job openings, more use, and more investment. So we have a few people in that workshop with venture capital background, some people who work and manage venture capitals, and they're going to talk about the opportunities that they see, some interesting startups to keep an eye on, some criteria, how to define the market. And we're also going to have someone who's on the other side of things. So Bob van Lout, who's a founder in a startup that actually just got funding recently, and he also uses those technologies. So that's going to be an interesting discussion from both ends of the spectrum. We also have a few master classes on day one. But before we talk about those, let's talk about your masterclass, Panos. And just to give you an intro about the idea of masterclasses. So as opposed to workshops where you have a number of people and we have a discussion pretty much like we're doing here, masterclasses are strictly hands-on, basically. So you have usually one instructor, sometimes two, but typically one. And the idea in masterclass is that this person gets to teach the attendees hands-on skills that they can use in their day-to-day job. So, Panos, let's hear what you are going to teach people.
Yes, thank you, George. So, yeah, my masterclass will be about using natural language processing techniques in order to build knowledge graphs, in order to build ontology knowledge graph from unstructured resources, so typically from text. It's a quite challenging task, but it's really important because if we really want to scale the construction of knowledge graphs, we cannot rely merely on manual work. On the other hand, it's not enough to say, yeah, let's use some information extraction tools or train any kind of machine learning and it will work magically. So it needs a proper methodology and to pay attention in particular pitfalls that might occur in the process. So the masterclass will consist of two parts of 2 hours each. The first part will start from how we prepare for mining knowledge graphs. And by preparation means defining a very basic schema that will guide us into how we're going to do the mining, selecting our sources from where we're going to get the data, selecting our tools, and things like that. And we will move forward to deeper things like how we extract entities from text that will populate our classes and our concepts, how we extract synonyms and hyponyms in order to be able to create taxonomies and to group strings into things, as Google likes to say. And then on going to more specific relations, associative relations, depending on the domain. We're going to be using open source tools. SpaCy will be one of them, and other frameworks like I think I have in mind, like TensorFlow or some basic. We're going to be using a lot of pre-trained state-of-the-art language models like BERT and whatever.
Okay, nice. Right, so that's one.
I want to follow that.
Pardon?
I want to follow that.
Of course, you're welcome.
Yeah, that sounds
me too.
great.
Sounds great.
Yeah. So yeah, Panos is actually, I think, is one of the more advanced, let's say, master classes that we have. We also have some others that are more entry level in a way. So we have one from Heather Hedden, who's one of the very well-known taxonomists and knowledge graph experts. So she's going to be talking, teaching actually precisely about that. So taxonomies as a foundation for building a knowledge graph. So her masterclass is also in 2 parts. So that's going to go, it's going to be quite extended. We have, again, another one which is kind of entry level, which is about a technology that I think was only briefly mentioned once so far in our discussion. So GraphQL. We have some people from Apollo GraphQL, which is one of the leading open source vendors in this space. So he's going to be talking about how to use GraphQL, how to use GraphQL schema and how to model things that way. It's an interesting variation from the kind of things we usually see in this space. Let's see what else. We also have a workshop about graph-powered machine learning. So that's going to be given by Jörg Schad from ArangoDB, who's again quite the expert on that. We have another one again on graph machine learning from Ebru Kuchen, who's going to be talking about how to use graph MLOps, as she called it. So again, an interesting one. We have a returning guest. So last year, one of our keynotes was Kirill Benzi, who talked about data art, and that was a pretty impressive keynote and one of the favorites from last year. So he's returning this year. This time, instead of giving a keynote, he's going to be delivering a masterclass, and he's going to be sharing the secrets of his trade, basically. So he's going to show how you can use different open source libraries to create data art. So that's going to be a really, really good one. Yeah, we also talked about Panos' workshop. We have another one from DBpedia. So the people from DBpedia are going to be giving I know that they do many tutorials and masterclasses around the year, but we've been in touch with them, and this one is going to be a bit different because most of their tutorials that I've seen so far are kind of more advanced, let's say. So we thought, let's make a more beginner-friendly one. So they're going to start really from the basics, like, okay, what is DBpedia? How can you use it? How do you get started with it? And then they're going to be progressing to a bit more advanced topics. And I think that's going to be a very good one, because I know many people who have heard of DBpedia and they'd like to use it, but they don't know how to get started. So this is the right masterclass for them. So yeah, lots of variety to choose from, and yeah, let's not forget the last one, which is a kind of more specialized topic. So if you're into drug discovery, basically, there's a masterclass for you as well. There's a library called right. Okay, I see some people have to sign off. So Ivo, thanks for joining. And thanks, Katariina, as well. And well, we'll stick around a little bit longer with you, Ashleigh, and Panos. And
I also need to go. Yeah.
All right.
It was great, all this. So yeah, to the attendees, I hope I see you in the conference.
You absolutely will. Thank you for popping by, and yeah, see you soon.